A father said to his son, 2 years ago, I was 3 times as old as you, but in 14 years, I shall be twice as old as you. What were the ages of each? So this problem has a little bit of a story. It was given to MIT students. I think it was given on an admissions test in 1878. And I got the problem from Presh Talwalkar, Mind Your Decisions channel. He did it using simultaneous equations, and you can use it. You can use his technique. I am going to do the problem or solve the problem visually. Let's see what we can do. So what I have here, I have the question right here, and I have a little table here, and I want to visualize the son's age and the father's age 2 years ago and 14 years from now. So let's say 2 years ago, 2 years ago, the son's age could be represented by this blue square. I don't know what the blue square is worth. It could be worth 5 years. So 2 years ago, this square can be, we can use the square to represent son's age 2 years ago. Now, according to the question, 2 years ago, the father was 3 times as old as the son. So I'm going to put 3 squares here. All right. Now, I know that in 14 years, the father ended up would be twice as old as the son, but I'm not going to worry about it too much. But I do know one thing. If 3 squares represent the father's age 2 years ago, and 1 square represents the son's age 2 years ago, to find their ages, I can also do this. It's perfectly legit and correct. I can also write 14 years from now, the father will be 3 squares plus 16, and the son will be 1 square plus 16. And I will explain to you where I'm getting 16 from. Now, 2 plus 14 is 16. Okay? This is the dad's age, 14 years from now. However old he was 2 years ago, to that you would be adding 14 plus 2 or 16. And this has to be the age of the son 14 years from now. As long as the son was 1 square old 2 years ago, he would be that same age plus 16. Now, the most interesting thing is this, but in 14 years, I shall be twice as old as you. I do know that this is twice this. Okay? So this portion is already here. A box plus 16, a box plus 16. Is same as this. So the other portion, 2 boxes, must also be box plus 16. So this representation here is 2 times this. This matches this. This has to be the other half. Therefore, I can conclude each little blue square is worth exactly 16. And you might want to process this well, how I can make that or draw that conclusion. So I'm going to conclude each square is worth 16 years. I'm going to just label 2 of them. This is 16. And so are these. Okay. So now they want us to find the father's age and the dad's age. So the father's current age is 16 times 3 is 48. 48 plus 2 is 50 years. And the son's age is 16 plus 2 is 18. And I'm done. That's my answer. I do want to make sure I didn't mess up. So we're going to check our work. We'll see if what I got is consistent with the question. Now, if their current ages are 50 years and 18 years, 2 years ago, the dad was 48 and the son was 16. And yes, the father was 3 times as old as his son. Now, 14 years from now, the father would be 64. Okay, let's write it down. 14 years from now, the father would be 64 and the son's current age is 18. 18 plus 14 is 32. And lo and behold, it turns out to be the case that 14 years later, the dad would be twice as old as the son. So I hope that makes sense. And I will give you the solution that Mind Your Decisions channel provided in the description below. That's also a good solution.